Hello students, this is an introduction video for class 8th chapter 12, that is exponents and powers. So students, let's start with the definition of base and exponent. The definition of base is the base number tells what number is being multiplied, and exponent, the exponent, a smaller number written above and to the right of the base number, tells how many times the base number is being multiplied. For example, a raised to the power n. Here a is the base and n is the exponent. For example, 2 raised to the power 5 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 is equal to 32. And the second example is minus 7 raised to the power 3 is equal to minus 7 multiplied by minus 7 multiplied by minus 7 is equal to minus 343. Now students, let's start with the very important topic, that is law of exponent. Students, let's start with the first law, that is product law of exponents. X raised to the power m multiplied by x raised to the power n is equal to x raised to the power m plus n. Students, according to the product law of exponents, when multiplying two numbers that have same base, then we can add the exponent. For example, 4 raised to the power 2 multiplied by 4 raised to the power 3. Students, you can see here base are same, so you should add the exponent here. That means 4 raised to the power 2 plus 3 is equal to 4 raised to the power 5. Next law is quotient law of exponents. X raised to the power m divided by x raised to the power n is equal to x raised to the power m minus n. So students, according to the quotient law of exponents, we can divide two numbers with the same base by subtracting the exponents. For example, 4 raised to the power 5 divided by 4 raised to the power 2 is equal to 4 raised to the power 5 minus 2 is equal to 4 raised to the power 3. Now students, let's see the next law, that is power law of exponents. X raised to the power m whole power n is equal to x raised to the power m multiplied by n. So, according to the power law of exponents, if a number raise a power to a power, just multiply the exponents. For example, 5 raised to the power 2 whole power 3 is equal to 5 raised to the power 2 multiplied by 3 is equal to 5 raised to the power 6. Now students, let's see the next law, that is law of reciprocal. A raised to the power minus n is equal to 1 upon a raised to the power n. Similarly students, a upon b whole power minus n is equal to b upon a whole power n. Students, we can say here, if we have a number with negative exponents like a power minus n, then we can represent it in the terms of a positive exponent by taking its reciprocal. For example, first example, 5 raised to the power minus 3 is equal to 1 upon 5 raised to the power 3. Similarly, the second example, 2 upon 3 whole power minus 4 is equal to 3 upon 2 whole power 4. Now students, let's see the concept of zero exponents. A raised to the power 0 is equal to 1. So students, the value of any number to the power 0 is always 1. For example, 5 raised to the power 0 equal to 1. Next example, 4 upon 5 whole power 0 is equal to 1. Next example, minus 5 raised to the power 0 is equal to 1. Now students, let's start the revision of law of exponents. The first law was product law. A raised to the power x multiplied by a raised to the power y is equal to a raised to the power x plus y. Next law was quotient law. A raised to the power x divided by a raised to the power y is equal to a raised to the power x minus y. Next is power law. A raised to the power x whole power y is equal to a raised to the power x multiplied by y. Next law is zero exponent. A raised to the power 0 is equal to 1. Next is negative exponent. A raised to the power minus x is equal to 1 upon a raised to the power x. Now students, let's see the next topic, that is scientific notation. Let's see its definition. Scientific notation is the system developed to write and read large number in short form. For example, 2, 8, 9, 12 times 0. Here we begin with decimal place, which is end of the digit. In this example, decimal place move from right to left and the decimal place move right to left until a single digit is left on the left of the decimal point. So students, for this number we move the decimal point up to 14 place to the left and the remaining digit must be lie between the digits 1 to 10. As here 2 lies between 1 and 10. So students, we can write the large number as the product of decimal place number with power of 14. That means it will be written as 2.89 multiplied by 10 raised to the power 14. Now students, let's see one more example, that is 0.000000203. Here move the decimal point to 8th place to the right to get a single digit to the left side. In this example, 2 is only digit which is left to the decimal and is between 1 to 10. So students, we have moved decimal point to 8th place to the right. So we can write this digit as 2.03 multiplied by 10 raised to the power minus 8. Students, this was the last topic for this chapter. Thank you.